left for 6 sections. And we have 2 classes for review. 1 class for test 4 review and 1 class for final exam review. Now, if in these 5 classes, roughly, it's less than 10 hours, probably is 9 hours or whatever, I didn't calculate. If we finish sooner, then we'll start reviewing, okay? Good. So as I mentioned, we start with 4.9 because 4.9 and 5.1 through 5.5 are together, and they will make up test 4. So these are the topics for test 4. And we start with 4.9. And the title here is, I will not talk about it as this right this moment. I have other little things that I want to talk about, and then I will name this, right? Anti-derivatives. Okay. So before I explain what this is, let's take a look at a function. So if we're given a function like, let's say, 3x squared plus e to the x, and let's say we're asked to find the derivative. I know you will say 6x plus e to the x. Now, if it happens that this let's say, is the velocity, what is this function? What does this function represent?
Position?
The distance, right?
Yeah.
So when I have the distance and I differentiate, I get the velocity. What if I have a function that, let's say, is the cost function? Not the distance, but the cost. And I differentiate it. What will this represent?
Cost over time.
Yes. So the rate of change of cost with respect to number of units or whatever.
Yeah.
This is called, it has a special name, marginal cost. But you're right. It's the rate of change of cost, of course, with respect to units, number of units. Now, if this one is profit, and this is going to be marginal profit, same thing, the rate of change of profit with respect to number of units. If this is revenue, this will be the marginal revenue, and so on and so forth. Now, what if I am given this function? So given f prime of x equals 6x plus e to the x. Let's say it's the velocity. And let's say we're asked to find the distance function. So let's suppose this is the velocity. And they're asking us now, find the distance function. The correct question here would be a family of functions with the same derivative, with the same derivative, exactly. Family of functions with the same derivative. Which derivative? This. Okay. So let's try to construct that, and then we'll talk about in more details. If the notation is given to us as f prime, and we're asked to find f of x, we want to construct step by step, find the function whose derivative is 6x. So I will copy 6, and I'm asking myself, which function prime is x? I have to increase the power by 1 and divide exactly by that number, the result. And you can say, wait a minute, show me. Yes, I will show you. When I differentiate x squared over 2, I get 2x over 2, and when I simplify, I get x. And this is a rule. What is the rule? The rule is x to n plus 1 over n plus 1. So when I differentiate this, I get x to the nth power. So going backwards from the derivative to the function, all I have to do is increase the power by 1 and divide by the result. This result, number 2, plus. Now, which function prime is e to the x?
E to the x.
E to the x. Because when I differentiate e to the x, I get e to the x. Plus, which function prime is 0?
Nothing?
A constant.
Oh, yeah.
Every constant prime is 0. So when I simplify, I get 3x squared plus e to the x plus a constant c. This is a family of functions. Many, infinitely many functions. How come? Because c can be anything from negative infinity to infinity. So this result is not one function, but a family of functions whose derivative is guaranteed to be this. And we can always check. 3x squared prime is 6x. E to the x prime is e to the x. Constant prime is 0. This also has another name. So 3x squared plus e to the x plus a constant c is a family of functions that has the same derivative, also called, this is also called, the most general antiderivative. Of function f prime equals 6x plus e to the x. So, what have we learned so far? We learned that we know how to go backwards. So if I'm given the velocity, I can determine the distance. If I'm given the rate of change of cost with respect to time, or in other words, the marginal cost, I can find the total cost function. If I'm given the rate of change of revenue, I can find the total revenue. Basically, a family of functions, many functions whose derivative is this. All these functions have the same derivative. Also, we learned the words, if you want, or the expression, the most general antiderivative, meaning going backwards. Now, 2 notations. Very important. Number 1, given f prime of x, we find f of x. Number 2, I could be given just a simple function, and to find its antiderivative, the notation would be uppercase f of x. Why? What's the big deal? Well, this comes from fundamental theorem of calculus. We're going to discuss this in chapter 5. So one more time, 2 notations. Again, is it such a big deal? Not really. But we need to understand this. If we're given f prime like we had in our little example, we determined f of x. If they're telling us here is a function, find its antiderivative, I have to use this notation. And again, I'll explain when we get to it in chapter 5 why this is so important. Okay. I would like us to practice now with examples, and I'll let you choose. I'll choose, you choose, I choose. But one other thing I was going to say. Let's say given f of x equals 3x to the 4th plus 3. Find f of x. So in other words, I'm given a function in the form of f of x, and I'm asked to find its antiderivative, the most general antiderivative. Sometimes I would be given something like knowing that f of 0 is 2. So this is a different, the notation is different, is this one, but it's slightly different because I am given something called initial value. Initial value. I'm given an initial value, which I will not be looking at this moment. So first I want to determine uppercase f of x. 3 stays in front. Which function prime, based on the power rule that we just looked at, which function prime will be x to the 4th?
Can you repeat that?
Yes, and I just wanted to show it also. So in order to find a function whose derivative is x, all I had to do is increase the power, which is 1, by 1, 1 plus 1, and divide by the result for polynomials. So now, which function prime will be x to the 4th?
X to the 5th.
Over 5. Because when we differentiate, we bring down 5, it cancels. We subtract 1 from the power, and we get this. Plus, which function prime is 3?
3x.
Excellent. And we can never forget, plus, which function prime? Exactly, plus c. Now, careful. When we look at the cost function, and if this is c of x, do not use c, please. So use d, use e, use f, use anything else. So there is no crash, right? Between the name of the, or the label, if you like, of the function and this constant. Good. So this is done. I determined the most general antiderivative, but now I am told that f of 0 is 2. Why do you think this condition is given to us? What for?
To figure out what constant exactly?
Exactly. Exactly. It's given to us to determine a unique function. It will no longer be a family of functions. It will no longer be the most general antiderivative. It will be just one. One function whose derivative is this and also passes through the point 0 for x, 2 for y. So f of 0 is 2, so I have 2, 0, 0 plus c. Therefore, c is 2. So we determined a unique function, 3/5 x to the 4th plus 3x plus 2. No longer the most general, no longer the a family of functions, but a unique function whose derivative is that, but also passes through the point 0, 2. Any questions on this? Okay, then I'm going to go to the book. I lost you guys. Okay, here's the book. We go to 4.9 and we want to practice finding antiderivatives. Here it is. So we're looking at the first set of problems. Okay. Five through 26. Find the most general antiderivative of the function. Check your answer by differentiation because we can. So 5 through 26, you choose.
Can we do 6?
Yes. So let's start with 6. My page 2, my page 3. Very good. So let's start with 6. And we have f of x equals x squared minus 3x plus 2. We're asked, we have no initial value. We're only asked to find the most general antiderivative, and we are always able to differentiate to see that that's the case. Because the notation is f of x, what do I denote? How do I denote the most general antiderivative?
Capital F of x.
Excellent. Which function prime is x squared?
Just x over 3 times 3.
To the third divided by 3 minus 3. Which function prime is x? I know it's confusing. We're going backwards now. We
It
increase.
is x squared.
Yes, we increase the power and we always divide by the same number. Plus, which function prime? That's why I always say which function prime is that, so it's easier to understand
Yeah,
what.
it's definitely like
X.
you gotta wrap your head around it.
Right. That's why I say I do this. So it's easier to understand and remember. Awesome. That's it.